Okay, so now going to start the simplex method. So in last videos I have explained the maximization problem by using graphical method. So in these videos I am going to explain the simplex method, and the question is the types of maximization types. And what is the simplex method? That is very simple. It is one of the best method that we use to solve linear programming problem. And here now I am going to apply this simplex method. So what is simplex? Sometimes generally some student ask me either it is simple or it is complex. So generally I said for especially for this method, so it is, sometimes you can say it is simple, or sometimes you can say it is a complex. Why it is simple and complex? Because especially this method needs more practice. If you give practice over some numbers of questions, then it is very simple. If you are not giving some practice, then it will become complex. So if you combine simple and complex, you will find the simplex. That's I think. Simplex is nothing. It depends on you. Either you are going to make it simple or either you are going to make it complex. That depends on you. So simplex method is one of the best method that we need to apply to solve any types of linear programming problem. Either the types of maximization or either the types of minimization. And any numbers of variables are applicable. Because in graphical method we are restricted over the two variables. But here there is no restrictions. We may use this method to solve any numbers of variables problem. So because here just I have taken the same examples, two variables equation. In the graphical method I have taken the another examples, but on that examples also the constraints under the two variables restriction. So I applied the graphical method, I solved. So you already have seen that video. Now I am going to apply the simplex method, and it is very easy, very simple method. Just be concentrate and try to understand the concept. So here first we need to write the same, whatever I have written here, just we need to copy. So whatever the objective function and the constraints and the decision variable have been given, just need to first copy. So we need to we are going to copy here maximization types of problems. So we need to write max zx1 plus 9 x2 subject to 3x1 plus 3x2 is equal to 21. Same, just you need to write this one, 4x1 plus 3x2 is equal to 24. x1 x2 are greater than equal to 0, because under the variables we are restricted under it will always be either 0 or greater than 0. It cannot be negative. So here now we are going to change these constraints into the equations form. So already have given in the form of inequalities. Now we are going to change into the forms of equation. So why we are going to change into the form of equation? Because in the graphical method also I have applied the same approach, and just we have taken some tabular approach and we went for the graphical representation. We have taken x1 and x2 axis of the graph and we draw the straight line and we find where it is going to be intersected and we solve the problem. But here there is we are going to apply the tabular method. So what the tabular method is going to say? Before, to make this equation from inequalities to the equation form in equal form, we need to add some variable. So it is very simple idea. If you are going to make this less than equal to values to equal to values, it means you need to add some value. So here we are going to first consider, because we don't know what is the values of x1 and x2. So just we are going to consider s1 and s2, s1 and s2 as a variable. Generally we called these two variable as a slack variable. So under the maximization types of problem, because we need to make it balance types of the problem, balance equation in the standard form, so we need to add the variable. This variable name is called slack variable. Why it is slack variable and why we called as a slack variable? So we will see in between the solutions you will find why we called as a slack. Because in the minimization types of problem we called as a surplus variable. So what is the meaning of surplus variable and why we called as a surplus? Sometimes we call to surplus variable as a negative slack variable. So both are same, don't get confused. So here in the maximization types of problem, if the constraints will be in the less than equal to, so we need to add S1, and these variables are called slack variable. Okay, so because we have added these two new variables, so just we need to write these two variable again, and these conditions will always be greater than equal to 0 because it is not going to be changed. Here the one question is going to be arise, either we need to make the changes in the objective function, or just we need to proceed by taking these questions. So because objective function, we cannot make changes over the objective function. Objective function itself is a solution. So solutions already exist inside the questions. So this is our solution. This is our solution. Just we need to find the values of x1 and x2 and put here into the objective function. So we will get the final result. So we cannot change the objectives. So we cannot change our objectives of the question. So objective functions of the question cannot be changed. So here, because we are not going to change, but we are going to introduce s1 and s2, because we are not we don't have right to change the objective function. So just we are going to write 0 s1 and 0 s2. So this result, this 0 s1 0 s2 will give the results 0. So objective function will be same as given into the question. So it is not going to be changed. So now next step, first we need to change from this form to this standard form. So now because we already have changed this form into the standard form, so just to forget what was the question, no need to remember what was the question. Now we will go to see these steps. After this steps, we need to go to draw the table. So to draw the clear table, just I am going to copy the same contents here. So here what I have written here, maximization, here just need to adjust, it is going to having some problem. Okay, now it's okay. So maximization types of the problem, just I am going to write here. So draw the table in clear way. So 10x1 plus 9x2 plus 0 s1 plus 0 s2 subject to 3x1 plus 3x2 plus s1. So we can write 1 s1 is nothing, 1 s1, and there is no s1, there is no s2, so we can write s2. Now it is 21. Here 4x1 plus 3x2 plus, because here there is no s2, there is no s1, so 0 s1 plus 1 s2 is equal to 24, and variable x1, x2, s1, s2 will always be greater than equal to 0. So now we are having the new equations. So it is same, because we are not going to make any changes over this equation, just we need to proceed it. Now because here this is our questions, just we have changed its form question, because here we need to get the solution. So just you find this itself is a question, just we have changed its form by adding the slack variable and to make the zeros in the objective function, to make as it is whatever the objective function have been given, that is our result. Now because I am going to solve this problem by using the tabular method, so we need to draw the table. Table is very simple. We need to draw here in this form CB XB. What is CB XB? I will explain you in the detail. Then you need to write B, then draw. It is fixed one. You cannot make any changes in the table. Whatever variables I am going to write, once you see the problems to apply the simplex method and solve the given linear programming problem, so just you need to draw a table in this form. This is very easy and very simple method. Just you need to remember which variables now you are going to write at which positions, and you need to just put the values according to their respective values. Now here how many variables we are having? x1, x2, s1, s2. Just write here. There is nothing, just you need to copy and draw a straight line to close this boundary. Now we have closed this boundary. Just you need to draw one more line to write the coefficient of given objective function. So the coefficient of objective function, generally we call the coefficient of objective function by the name of Cj. So very simple, just you need to remember Cj is nothing, Cj is the coefficient of objective function. So because it is 10x1, so you need to write here 10x1, 9, x2, 0, s1, 0, s2. So just have copied, nothing else. Next, because Cb is nothing, Cb is called coefficient of basic variable. xb is called basic variable. Sometimes we called as a basis. So don't get confused. In some books have written basis, in some books have written basic variable. B, the right hand side value of value of given constraints. Right hand side values of given constraints. Cj is the coefficient of objective function. So now it is clear. Now you can see what is Cb. Cb is the coefficient of basic variable, xb is the basic variable, b is the right hand side of the constraints, x1, x2, s1, s2 is called the variable, x1, x2 is the decision variable. So now you can write here x1, x2 decision variable, and s1 and s2 are called slack variables. So now I have given all these name. And how to define all these values? Once if you go through the problems, and in between you will find the definition, and by the problems steps itself you will be able to answer the questions. So no need to write, no need to go into the depth of these details whatever I have given into the books. No need to go to see the books. Just you go through with the process. By the process itself you will come to understand how to define all these terms. Okay. So now Cb is the coefficient of basic variable, xb is the basic variables itself, b is the right hand side of the values of given constraints, Cj is the coefficient of objective function, x1, x2 decision variable, already have seen in the another method also, s1 and s2 is the slack variable we have introduced into the questions. So now you already have got all these variables name. So now I am going to proceed step by step. Just you need to remember the steps, then it is very easy process. So you cannot say it's a simple, you cannot say it's a complex. It's a very simple and very very easy, very simple and very useful method. So that's why we generally call the simplex method is one of the best method to solve the linear programming problem. So which variables is going to be considered as a basic variable? So we will see here. First you need to write what is the b value. B value is 21 and 24. So now just you write this b value here. Okay, and see the coefficient in the 21, in front of 21 3x1. So in this respects whatever the variable have been given, just you need to copy 3x1, 3x1, here it is x2 not x1, 3x2, 1 s1, 0 s2, same 4 x1, 3 x2, there is no s1, so 0 s1, 1 s2. Just you need to copy whatever the values, whatever the coefficients have been given in these constraints. So just you need to copy, and here I am going to give one new name, theta. What is this theta? Just we will explain. Whatever variables have been given here, all these variables have their specific meaning. So theta is what? Theta is a ratio of this B1 and the key column values. What is the key column? How to find the key column? We will see now in the next steps. So here which variables is going to be considered as a basic variable? It is very easy, very simple way. Just you need to see which matrix is going to give you the unit matrix. So by the help of these two variables S1 and S2, now you are going to get the unit matrix. So wherever you are going to get the unit matrix, just without seeing the anything, just you may need to write this variable as a basic variable. Whatever variables are going to form a unit matrix, you may consider that variable as a basic variable. And in initial table, generally we consider the select variable, whatever we introduce into the constraints to make the balance, to make the equations. So that variable generally we consider as a basic variable in the initial table. So this table generally we call as the initial table. So in the initial table, you can see the coefficient of basic variable. So this is the basic variable and its coefficient is 0. You can see into the objective function also. So the coefficient of S1 is 0, coefficient of S2 is a 0. So just you write 0 and 0. The next step, you need to find Zj. What is Zj? I will explain you in the detail. Zj is nothing. Zj is very simple. Zj is what? Just you need to multiply this value to this value. You need to multiply this value to this value. So 3 into 0, 0, 4 into 0, 0, and add. So 0 plus 0, 0, 0 into 3, 0, 0 into 3, 0, 0 plus 0, 0, 0 into 1, 0, 0 into 0, 0, 0 plus 0, 0, 0 into 0, 0, and 0 plus 1, 0, 0 plus 0, 0. Because Zj in the initial table, always in the initial table you will get the Zj value 0. So why I am going to write here Zj? Because in the next steps the procedure will be same. So we need to find the Zj by using these steps. So now because we know in this step Zj will always be 0. So in the initial table you no need to find the Zj. You can write directly Cj minus Zj also, no problem. You can write Cj minus Zj. What is Cj minus Zj? So Cj is the coefficient of objective function. So already we have written here the Cj 10, 9, 0, 0, and Zj we already have found here in this table. So now we are having the Cj and Zj. Just go its respective values and subtract. So Cj is 10, Zj is 0. So 10 minus 0, 10, 9 minus 0, 9, 0 minus 0, 0, 0 minus 0, 0. Now we have subtracted. So in first table in the sense initial table. So in initial table you no need to go to find the Zj. You no need to go to find the Cj minus Zj. Simply you just copy the Cj value, that itself will give you the Cj minus Zj. So no need to go up to that steps. You can write direct, because just you see here whatever I have given in the coefficient of objective function, just you need to copy, that will give you Cj minus Zj. Simply just you copy. So no need to go up to that step. Just you write the simply Cj minus Zj. Whatever I have given in the coefficient of objective function, just you copy and write here itself. It will give you result Cj minus Zj. So now Cj minus Zj is what? Cj minus Zj is, just copy 10, 9, 0, 0. In first step you no need to go to find the Zj, and then you no need to go to subtract from Cj minus Zj. Simply just you write Cj minus Zj and copy the coefficient of objective function. So now table 1. And what is the meaning of Cj minus Zj? We need to find the largest positive value to get the key column. So out of these, all these values, which one is the largest positive value? So out of these values, 10 is the largest positive value. So we will consider these 10 to find the key column. But where we have to stop? Because now this is the initial table, then we will move into the first table, then we will move into the second table, then third table, then fourth table. So where we have to stop? So where we have to stop, the condition is very simple. Wherever we will find Cj minus Zj value less than equal to 0, either it is negative or 0, then we will stop and we will see what is the values of x1 and x2. So now this is the condition. So this is the condition you need to remember to stop the procedure and find the result. So now here just check here Cj minus Zj, no, either it is 0 or greater than 0, so we cannot stop here. we need to find the largest positive value of Cj minus Zj. So this 10 is the largest positive value of Cj minus Zj. So now we have selected this 10. We have selected this 10. So this largest positive value will give the key column. So this column is called key column. So this column name is called key column. So this column is called key column. Then now what this arrow is going to show you? This arrow is going to show you first to select the key column, and parallel it is going to introduce. Now go up to the up and see which variables is going to touch. So if you go up and up, now x1 is going to be introduced. It means x1 is going to enter into the basis. So this is the basis, this is the basic variable, this also called the basis. So here x1 is going to enter into the basis, and wherever it is going to enter into the basis, that variable is going to leave the basis. So out of these s1 and s2, which variable is going to leave the basis? That is the important thing, because our aim is very simple, to make, because here this is the objective, this is the basic variable. So our aim to make this matrix, just see here 3 3 4 3, because x1 and x2 are having this matrix. So our aim to change this matrix to unit matrix. Once you change this matrix to unit matrix, automatically s1 and s2 will get removed from this basis, and x1 and x2 will enter into the basis, and you will get the result. So our aim to make this matrix, to change this matrix to unit matrix. So now how to change this matrix to unit matrix? There is some certain steps. So just we need to proceed through the steps. Automatically we will see this is got key column. So just I am going to write here in key column. So just see here, key column already have got. Next step, to find the key rows. Before going to find the key rows, we need to find the ratio. What ratio? B divided by its respective key column elements. So B is 21 divided by 3, that is 7, and its respective 24 divided by 4, that is 6. Are you getting? Very simple. To find the ratio, to take the values of B and go its respective key column elements and divide this B by its key column elements, so we will get the ratio. Why we are going to find the ratio? We are going to find the ratio to get the key rows. So this is here, out of these two values 7 and 6, which one is the least positive value? To find the key column, here we need to go to find the largest positive value, but here to go to find the key rows, we need to find the least positive value. So this 6 is a least positive. Out of these 7 and 6 is a least positive. So here it is very simple, just we need to circle this, this row, circle this row. So this row is named key row. This row name is key row. Now we are having key rows and key column. Why we are going to find key rows? There are so many aims to find the key rows. First, to find the intersection of key column and key rows. So intersection of key column and key rows are going to give this 4. This 4 is the intersection of key column and key column and key rows. So now, because this is the intersection of key column and key rows, so name of this is key element. So just I am going to write in the abbreviated form key element, KE, key element. So how to find the key column? To find the key column, we need to go to the largest positive value of Cj minus Zj and mark the arrow upside. And to find the key rows, we need to go to find the least positive values of these ratios. So this is called minimum ratios. So here these key rows and this key column are going to give you the key element. Now initial table is finished. Now we need to move into the next table, that is table 1. What is table 1? Table 1 is very simple. Just you need to copy the same table, whatever I have given here. Just you copy this table. I am going to copy. Simply just copy whatever given. Here I have given Cj. Just copy Cj. Then next I have given Cb. Next have given CB. So just copy here CB. Then have given XB. Then have given B. Simply you need to copy. Just we have copied. Here I have given X1 and X2. X1, X2, S1, S2. Then here I have given theta. So just you need to copy. Here I have given CJ. So just you need to copy this CJ. CJ already have copied. Just you need to come up to this point and cover this. You will get this is the theta. But here the concept, then 10. Just copy. This one is not going to change. In any table, these things will be common. So here we are not going to make any changes. Where we are going to make the changes, it is very simple to remember. First, because my aim to change this matrix to the unit matrix, so here just we need to concentrate, because now this steps is very important to remember. Then only you will move from first table to the another table and you will get the solution. So here it is very simple. To make this as a unit matrix, first we need to change these 4 to make as a 1. Then only we will get the unit matrix. So now I am going to make some changes over this one. So here just you see where we are going to make the changes. Just we need to make the changes here in 4. So 4 divided by 4 we can write 1. So now it is going to give the unit matrix. So our aim is going to be fulfilled. So opposite to this 4 we need 0. So now we can put here 0. We are not going to make any changes at anywhere else. So how we are going to get this 1? It means we are going to divide this key element by itself. So 4 divided by 4 we can get 1. So now here first don't write. So you will get the confused. First you need to complete this row. So you need to divide this key element by itself, so it will give you 1. So because it is going to give you 1, so you need to divide all these values by this 4. So 24 divided by 4, 6. 3 divided by 4, we need to write 3 by 4. 0 divided by 4 going to give you 0, and 1 divided by 4 will give you 1 by 4. Now we are having this result. Okay. Next, so this result, and which variable is going to enter into the basis. So now here we can see very simple way. Whatever the key columns have selected, this variable will enter into the basis. Whatever the key rows have been selected, this variable is going to leave the basis. It means x2 is going to leave the basis and x1 is going to enter into the basis. It means at the place of x2 you need to write x1 and its respective coefficient, just you need to write the coefficient of basic variable, because now this variable, now because here x1 and x2 is going to be changed into the form of unit matrix. So now x1 is going to change into the form of unit matrix. So now we can put here 0, because this one already have decided. Here anyhow we need to find the 0. So how to get this value 0? That is, there is some procedure. Just you need to remember these steps how to find this value as a 0. Here first you need to write where we are going to make this 0, where we are going to make this value 0 in these rows other than key rows. So other than key rows, this rows is called other than key rows. So we are going to make changes in other than key rows. So just write old value. Old values is nothing, old values from old table. So this is the new table. We are going to create this table as a new table. This table is called old table. So take these values from the old table. So this is the 21. Then next 3, then 3, then 1, then 0. Write vertically. Write vertically. Why we are going to write vertically? To make these values as a 0, we need to make some changes. And the procedure here, to put negative here and give some constant value, which values are going to be considered as a constant value, to write here and multiply all these constant value with new table values. So what is the new table values? In the respect of 21, this is the 6, 1, 3 by 4, 0, 1 by 4. Just write here 6, then 1, then 3 by 4, then 0, then 1 by 4. Just calculate and see what is the result. So where we are going to make changes, where we are going to make zeros at which position? At the position of 3. It means now 21 have considered as a first one, 3 has considered as a second one. So now we are going to make changes in this position, because zeros is going to come at the position of 3. So already we are having 3. If we will put here 3, it means it is going to give the 0, because 3 minus 3, 0. So we need to put this 3 in all these box. This is the constant value. Now here 21 minus 18 result 3. 21 minus 18 result 3. Here 3 into 3, 9. 9 by 4. 3 minus 9 by 4. So here 12 minus 9 by 4, it means 3 by 4. So this result will be 3 by 4. Now here 1 minus 0, result will be 1. 0 minus 3 by 4, so minus 3 by 4. So whatever value now you have got there, just you need to copy here. So 3, just go up to the 21 and copy here. Now here what is the result? 3. So just we need to write here 3. Here already we are having 0, so 0. Then next 3 by 4. Just copy all these value 1. Then minus 3 by 4. Now up to this step. Now I think it is very simple, and I think we have got all the steps. Now then next we need to find Zj. We need to find Zj. Once you got the Zj, then we need to find Cj minus Zj. This is the steps. I think you are getting very clearly, because it is very easy. Why we have introduced in initial table Zj to get the result of Zj? Same procedure I am going to apply over this table. Okay, so here we are not going to make changes over these S1 and 0. So just we have made changes in this row and just copied S1 and S2. So in this table we are going to see which variables is going to leave the basis and which variable is going to enter into the basis. So first we need to find the Zj. It's very simple. 0 into 0, 0, 10 into 1, 10, 0 plus 10, 10. 0 into 3 by 4, 0, 10 into 3 by 4. So 10 into 3 by 4 is what? 10 into 3 by 4. 15 by 2. 15 by 2. So you need to write here 15 by 2. Next 0 into 1, 0. 10 into 0, 0. So 0 plus 0, 0. 0 into minus 3 by 4, 0. 10 into 1 by 4, 5 by 2. 10 into 1 by 4, that is 5 by 2. Cj minus Zj is very simple. Cj is already 10. So 10 minus 10, 0. 9 minus 15 by 2. 9 minus 15 by 2. 3 by 2. 3 by 2. So you need to write here 3 by 2. 0 minus 0, 0. 0 minus 5 by 2, minus 5 by 2. Okay. So now here, just to check, we are going to get Cj minus Zj. This condition is going to fulfill. Just you check. This condition is going to fulfill or not? Cj minus Zj. Cj minus Zj must be less than or equal to 0. Then only we can stop. So Cj minus Zj 0. 3 by 2. No. 3 by 2 is a positive. We cannot stop. 0 minus 5 by 2. This condition, these values are going to satisfy this one. But this 3 by 2 is not going to satisfy the condition. So we cannot stop here. We need to proceed for the next table. So for the next table, this table name is called initial table. So initially we have defined, this table is called, you can give the clear name. This table, first table is called initial table. This table 1. Now to move from initial table to table 1, we need to get the support from this table. To move from table 1 to table 2, we need to forget this initial table. No need to remember this initial table. Just we need to move from table 1 to table 2. So just forget whatever we did the calculation, whatever values was there in the table, initial table, no need to remember. Just forget. So now we're going to forget initial table. So I have erased all the contents, whatever written here. See here. Now going to create the table 2. Now I am going to create the table 2. So now we can see how to draw table 2. very simple procedure, same procedure. So just we need to copy all these things, because these things are not going to be changed. Cj will be the same, whatever I have given here. Here Cb is not going to be changed, Xb is not going to be changed, B is not going to be changed. Just you write x1, x2, s1, s2 is not going to be changed. Theta we need to find, and just close this value, just close this one. Just we need to write in a clear way, just we need more space to write here two variables. So here we can take like this. So here we can write two variables in very clear way. Now here which variables? Because here see here how to find the theta. Theta is nothing, theta is its 3 divided by its key column element. Which column is going to be considered as a key column? Not this 3 by 2. So this column is going to be considered as a 3 by 2 because it's the largest positive value of Cj minus Zj. So this column is going to be considered as a key column. Now how to find the theta? Theta is very simple. Take the values of B and divide by its respective key column elements. So 3 divided by 3 by 4. To solve this one, to change 4 by 3, so we can write like this. This is the 4. So we can write here this value is 4. To get these values, similarly 6 divided by 3 by 4. So 6 into 4 by 3 to the 6, 4 to the 8. So you need to write here 8. Now it is very simple. Now we have got this theta value. Out of these two theta values we need to find the least positive value. So which value is going to show you the least one? This 4 is going to show the least positive value out of these two. So we need to cover this row. This row will be called as a key row. Now key row we have got key column and key rows. Intersection of key column and key rows are going to give you the key element. So what is our aim? Our aim to change this value to 1. Then only we will get the unit matrix. It means we need to get here 1. So now how to get this one? It means we need to divide this value by itself. So 3 by 4 divided by 3 by 4. So it will give 1. So now here also we need to divide 3 by 3 divided by 3 by 4. 3 divided by 3 by 4. It means 3 into 4 by 3. So result is 4. So now we are going to write here. This is the 4. 0 divided by 3 by 4. 0. 1 divided by 3 by 4. 4 by 3. Minus 3 by 4 divided by 3 by 4. Minus 1. Now this column, these rows have got completed. And here x1 is not going to be changed because this one already have replaced with other variable. So s1 here s2 have already leave the position and x1 have taken its position. So here we are not going to make any changes. Where we are going to make the changes? We need to make changes here. So which variable is going to be entered? Just you can see here x2 is going to enter into the basis, and here s1 is going to leave the basis. It means at the position of s1 we need to write x2. Once have written x2, just go its coefficient and write here. So now up to this steps I think you have got this. Here we are not going to make changes, so just you copy 10 9 0 0. Here we are not going to make any changes. Just see here how to get this value. Already have introduced into the last table how to get this value. So just we need to go into the old values. What is the old values here? Because we are going to make the changes. Where we are going to make the changes? We are going to make the changes here because this is key element value. So here we are not going to make changes. We are going to make changes in other than key rows. So just we need to write old values of x1. So old values of x1 is 6 1 3 by 4 0 1 by 4. Old values of x1 means from the old table. So 6 1 3 by 4 0 and 1 by 4. Just take the values of x1 from old table. So 6 1 3 by 4 0 1 by 4 and write negative from all, and just you need to find the constant value to write here, and you need to multiply with new result. What is the new result? So now new result is 4 0 1 4 by 3 and minus 1, and you need to find this value and just write here. So what this values is going to give you, which values you are going to make 0, just see here where we are going to make the 0, because these values already have got changed to 1. It means we have started from here, from this step. So 1, 2, 3, at the third step we are going to make 0. So 1, 2, 3, here we are going to make 0. It means here 3 by 4 already here, so we need to write 3 by 4. So 3 by 4 minus 3 by 4 will give you result 0. So just you need to write 3 by 4 in all these boxes, so it will give you result 0. And the second way to find the, other than the key element, you can take values, so itself will give you 0. So here 4 and 4 is going to be cancelled, 6 minus 3, 3. Here it is going to give the result 0, so it will be 1, 0, and this one will be cancelled, so this one is going to give minus 1, and 1 by 4 plus 3 by 4, 4 by 4 will give you the result 1. Just copy all these values, 3, 1, 0, minus 1 and 1. Now we have got all these values. Now whatever values we have got, just we need to forget what was there in the previous table. So here we need to find Zj. How to find the Zj? Zj is very simple. To find the Zj, just we need to multiply this value to this value. 9 into 0, 0, 10 into 1, 10. So 0 plus 10, 10. 9 into 1, 9, 10 into 0, 0. So this value will be 9. 9 into 4 by 3 plus 10 into minus 1. So 9 into 4 by 3 plus 10 into minus 1. 10 into minus 1. Now we are going to just multiply 9 into 4 by 3 plus 10 into minus 1. So 3 is 9, 4 into 3, 12 minus 10, this is 2. So just you need to write here value 2. 9 into minus 1, minus 9 plus 10. So minus 9 plus 10, result 1. So now we have got the Zj. So next we need to find Cj minus Zj. So here to find the Cj minus Zj in this table, just you write Cj minus Zj. So Cj already we are having here 10, 10 minus 10, 0, 9 minus 9, 0, 0 minus 2, minus 2, 0 minus 1, minus 1. Now check, simply check here Cj minus Zj. In all the table we need to check Cj minus Zj, either is it less than or equal to 0 or not. So now Cj minus Zj 0, okay, 0, okay, minus 2, okay, minus 1. It means now this condition is going to be fulfilled. So now we need to stop the procedure to go into the next table. So now this table there is no need, because this table work is already over. Now we have got the solution into the table 2. Initial table, table 1, and we moved into the table 2. Now you can see here x1 and x2 are going to give you the unit matrix. Once you got the unit matrix, it means your procedure is going to be stopped, because you already have made x1 and x2 as a basis. You entered x1 and x2 into the basis. So now it is going to show x1 and x2 is a basic variable. So and it is going to give you the unit matrix. Now you can stop here. So once you stop, just you see in front of x1 what values you are going to get. In front of x1 3, just check b value. In front of x1 3, and in front of x2 4. So you already are having the values of x1 and x2. I already introduced, this is our solution, this is the objective function, this is our objective to get the solution. So just you write z is equal to 10x1 plus 9x2. 10 into what is the x1? 3 plus 9 into x2, what is 4. 10 into 3 30, 9 into 4 36, it means 66. So now we have got x1 is equal to 3, x2 is equal to 4, and z maximum value we have got 66. So this is our solution. So I think it is very simple way to remember and proceed step by step to get the solution. So I think you all have got the procedure, and you understood the procedure, how to proceed from the question to the procedure and get the result. So I hope you all have got the steps and procedure. Okay, thank you very much.